Good morning. Welcome to Current Chem World. In this video, let us see what are precipitation titrations. It is also known as argentometric titrations. There are three types of precipitation titrations. And what are adsorption indicators? Adsorption, it is very important. What are adsorption indicators? We'll see. Okay, now what is the principle of precipitation titrations? Precipitation titration is a titration where precipitate is formed which is insoluble, which is slightly soluble or insoluble. For example, silver nitrate is taken in burette, potassium chloride is taken in conical flask. On titration, silver nitrate reacts with the potassium chloride to form silver chloride white precipitate. Okay, so this is an example of precipitation titration. Okay, what are the requirements, basic conditions for precipitation titrations? The reaction must be very fast and complete. The precipitated compound should be of reproducible composition, that is repeatability. Reproducible, the composition should be constant and of low solubility. And third, there must exist a method to locate the end point of precipitation titration. Okay. Precipitation titrations are also known as argentometric titration. What are argentometric titrations? They involve silver salts and are called argentometric titrations. In Latin, silver is called argentum. Okay, silver salts give insoluble precipitate with this halide and pseudo-halide ions. So, argentometric titration can also be used to determine these anions, pseudo-halide anions, halide anions. The reaction rates of the precipitation is very fast. For these anions, the reaction ratio is 1:1 and silver salts formed should be insoluble or less soluble, very less soluble. Okay, there are three types of precipitation titrations or argentometric precipitation titrations. They are MOHR'S method, VOLHARD'S method, FAJAN'S method, adsorption indicator method. This method is called adsorption indicator method. Okay, let us first study MOHR'S method. This is a direct method. It uses potassium chromate as an indicator in the titration of halide ions as analyte. On titration, silver nitrate is taken in burette, potassium chloride is taken in conical flask and 3 drops of potassium chromate as indicator. Okay, now there are equal possibility. Potassium chromate, silver chromate can be precipitated or silver chloride may be precipitated. But since silver chloride is precipitated first because it is less soluble than silver chromate, so silver chloride is precipitated first. After all silver chloride has been precipitated or consumed as white, the first excess silver plus, okay, forms a red precipitate, silver chromate. Okay, silver chromate as red precipitate. And these reactions occur at neutral or slightly basic medium. The second method is VOLHARD'S method. In this method, potassium thiocyanate is taken in the burette and silver nitrate is taken in the conical flask. Okay, it is reversed in this, and a few drops of ferric salt as catalyst, as indicator. Okay, So on titration, on adding potassium thiocyanate to the conical flask silver nitrate, the first thiocyanate is precipitated by silver nitrate. So thiocyanate reacts with the silver ion to give silver thiocyanate as white precipitate. Okay. Similarly, when all silver has been consumed, okay, a red complex is formed at the end point as a result of this reaction, because all Ag plus has been consumed. So Fe3 plus reacts with the thiocyanate ion to give red complex, this complex at the end point. There is a sudden color change. Okay. So this reaction is also used for blood without knife experiment. Okay. This method, VOLHARD'S method, is suitable for determination of halide ion also, not only potassium thiocyanate, for halide ions in acidic solutions by back titration method. Okay, in this, potassium thiocyanate is taken in burette, silver nitrate is taken in conical flask. The indicator is ferric ion, 3 drops or 4 drops. The end point is the formation of red complex. Okay, let us see the third FAJAN'S method. This method is known as adsorption indicator method. This method uses organic dyes, organic colored compounds such as dichlorofluorescein, fluorescein and eosine as adsorption indicators. In this titration, in burette, silver nitrate is taken, and in conical flask, potassium chloride is taken, and indicator 3 drops of fluorescein is added. Okay. Before the end point, it is greenish yellow because there is no adsorption. At the end point, the indicator is adsorbed on the silver chloride precipitate to form pink color. Okay, so the indicator is adsorbed onto the surface of the precipitate at the end point to give the color change from greenish yellow to pink. The adsorption process causes a change in the color of the indicator. Common adsorption indicators are, for example, organic compounds. They are weakly acidic and they exist as anions. They exist as conjugate base anions. Okay, so you see now at the start, in the beginning, when you add silver chloride is precipitated. Silver chloride, in the presence of excess of chloride, okay, silver chloride precipitate is negatively charged before end point because of excess of chloride ion, unreacted chloride ion. So it will be repelled by the AgCl precipitate is negatively charged. Therefore, indicator anion cannot bind to the precipitate because the precipitate is negatively charged. At the end point, there is no Cl minus. Okay, so there will be excess of Ag. So silver chloride will be absorbed by excess silver ion. Okay, therefore now at the end point, silver chloride is positively charged by Ag plus adsorption. Therefore, indicator is adsorbed on it to give pink color. Okay. So this is the summary of 3 methods I have given here for comparison and differences. Okay, for chloride ions, fluorescein is used as adsorption indicator. Okay, and for bromide and iodide ions, Eosin is used as adsorption indicator. Okay, before titrate, before end point, it is greenish yellow in solution, fluorescent, as you know, greenish yellow fluorescent solution. Okay, once it gets absorbed at the end point, it changes to pink color precipitate. Okay, similarly, eosin before end point, the indicator eosin is in yellowish red. After adsorption on the precipitate, the color changes to reddish violet. Thank you for watching. Please share and subscribe. Thank you again.